In this video, we're going to look further into complex numbers, and we're going to see complex numbers can be used as zeros of a polynomial. So let's look at example 7. Given that 3 is a zero of f of x is equal to x cubed minus 3x squared plus 100x minus 300. Factor as product of linear factors. So keyword here is linear factors. We want all the factors to have x being to the first power. So first, let's perform synthetic division so we can find the quotient after you divide this polynomial here by the factor x minus 3. Since 3 is a zero, so the factor will be x minus 3. So the coefficients are 1, -3, 100, and -300. First, dropped out the 1. 1 times 3 is 3. -3 plus 3 is 0. 0 times 3 is 0. 100 plus 0, it's 100. 100 times 300, or times 3 is 300. And add these two, we get 0. So, after dividing this polynomial, the original polynomial, by the factor x minus 3, we should get the quotient that has these coefficients. And these coefficients are the coefficient of the polynomial. Now, since the degree here is 3, so that means I should start here with x squared, and then x, and then 100. So it's really just x squared plus 100. Okay, so when you factor x cubed minus 3x squared plus 100x minus 300, we get x minus 3 and then x squared plus 100. So notice that this factor here is not a linear factor, it's a quadratic factor. And we want all of them to be linear factors. So we're going to need to find more zeros that are in here. To find the zeros of x squared plus 100, we can just set it equal to 0 and solve for x. So subtract 100 from both sides. We should get -100 over here. And then take the square root of both sides. That should give us x, and then plus or minus. So remember when we talked about complex numbers or imaginary numbers, this will become I square root of 100. And that can be simplified to plus or minus 10i. So to complete factoring, we should write x minus 3 is the first factor, and x squared plus 100 can be written as x minus 10i. So that's positive 10i being a 0. And then we have negative 10i being the 0, so the corresponding factor would be x plus 10i. And now you can see all the factors are linear. Here's a little fun fact. If f of x, it's a polynomial with real coefficients. And if a plus bi is a zero of f of x, then its conjugate, a minus bi, is also a zero of f of x. Let's look at example 8. Given f of x is x to the 4th minus 6x cubed plus 28x squared minus 18x plus 75. And given that 3 minus 4i is a zero of f of x. Now, first of all, because 3 minus 4i, which is a complex number, is a 0, so we can claim that 3 plus 4i is also a 0. Okay, so the one strategy here is to use synthetic division twice using the two known zeros here. So first, let's use it on 3 minus 4i. Coefficients are 1, -6, 28, -18, and 75. Bring down the 1. 1 times 3 minus 4i is 3 minus 4i. Add these two, -6 plus 3 is -3 minus 4i. Multiply. Now multiply these two together. Let's do it on the side. So we have 3 minus 4i times -3 minus 4i. Using FOIL, so that's -9 minus 12i plus 12i and plus 16i squared. These two cancel. I squared is negative 1. So we're looking at negative 9 minus 16. That would be negative 25. And that's what we're going to put here. 28 minus 25, that's going to be 3. 3 times 3 minus 4i, just use distribution. So 3 times 3 is 9. 3 times negative 4i is negative 12i. Add these two together, that's negative 9 minus 12i. We have to multiply again, these two together. So let's do it on this side. So negative 9 minus 12i times 3 minus 4i. We're going to use FOIL. Negative 9 times 3, negative 27. Negative 9 times negative 4i plus 36i. Negative 12i times 3, negative 36i. And finally, these two will give you positive 48i squared. Now, these two terms cancel. So we have negative 27 minus 48 because I squared is negative 1. And that will give us negative 75. So we're going to put negative 75 right here. Add them up, give you 0. So what does this tell us? These are the coefficients of the quotient. If we were to take this function, f of x, and you were to divide it, or think of as factoring. If we factor, first of all, since this is a 0, that means the corresponding factor would be x minus that 0. So it looks like that. So we would do x minus 3 minus 4i. That's 1, 0. And then this quotient that we have here is exactly what's highlighted up here, but we're not going to even going to attempt to write all those complex numbers as the coefficients. In fact, we're going to continue to break this quotient up even further by taking that quotient and divide by the second known 0, which is 3 plus 4i. And we're going to use those coefficients that we just found. So 1, negative 3 minus 4i, 3, and negative 9 minus 12i. So bring down 1. 1 times 3 plus 4i is 3 plus 4i. Add these two, everything should cancel, give you 0. 0 times 3 plus 4i, that's 0. 3 plus 0 is 3. And then times these two, just distribute. So 3 times 3 is 9. 3 times 4i is plus 12i. Add these two, you get 0. Oh, finally, we get a quotient that involves real numbers. So looking back at the original function, this is the degree of the function is to the 4th power. Now, we already performed synthetic division once, so this one is x cubed right here, but we continue to divide that. So down here, it would be down to x squared. So it's really just x squared plus 3. So to find the rest of the zeros, we're going to let that x squared plus 3 equal 0, and then subtract 3 from both sides, and then take the square root of both sides. So we have x is equal to plus or minus. This will become I square root of 3. So now we found all the zeros. The zeros are, let me highlight in pink, 3 minus 4i, 3 plus 4i, and then positive I squared of 3 and negative I squared of 3. So let's write all the factor as the product of linear factors for this function f here. So f of x at the end, it can be factored to the first corresponding 0 is x minus 3 minus 4i. Okay, and the second 0 is 3 plus 4i, so that would be x minus 3 plus 4i. We do want to make sure that you put parentheses around that, that 0 because there are multiple terms in there. And then the last two zeros, That's going to be x minus I squared root of 3. That's one factor. And the last factor is x plus I squared root of 3. Now, as you can see, all factors have x being to the first powers. That means they're all linear factors now.